electrified building. So what that means is their goal is to have a net zero energy building. Whatever they consume, they should be able to produce either using solar energy or other renewable source of energy. They were getting there. The project that we did is reduce energy cost. Customer goal was achieve net positive energy use. So generate energy on premise. So what was our methodology? So we go there to understand what's going on. Like, why are they paying so much for their energy? I mean, we were the consultant as well as the implementer with their team. So our methodology was like, okay, what kind of smart controls they have? Okay. So first we said, let's start tracking down the energy used on each floor. Okay. How we can do that? Like smart meters. Schneider meters are very good at the circuit level energy consumption. So we track like few circuits. We brought in R0 tracking occupancy data to see the correlation between the occupancy to the energy usage. Like what's the correlation between it? Like where can we reduce the energy if the occupancy level is going down? What kind of automated controls we can do? And then solar energy. One of the funny things about solar is like many customers think that they will save energy, they will save the cost if they go solar, but they don't. Okay, I worked in the solar industry. They don't save. Why? Because they don't know what it requires to utilize the solar energy better. First of all, batteries. Batteries are very important if you want to save the cost using solar, but batteries are costly. So many homeowners or even the commercial owners, they don't get batteries. And when they analyze the savings by going solar, they are like, no, I did not save any cost with solar, especially in Utah. Okay, I mean in Utah, solar without battery does not make any sense. And then we implemented smart HVAC controls to save the cost. Okay. So how we did it? So we brought in like open source IoT platform. Okay. We used the Schneider electric meters. Like we actually looked at a lot of smart meters and finalized this power logic meter from Schneider, which can collect the data from circuits. So we implemented it on various circuits on various floors to understand the data from various floor levels, like floor 1 versus floor 2 versus floor 3. Is there any relationship between like HVAC system on floor 2 versus floor 1? Okay, and then we brought in these occupancy sensors to look at like how many people are there and looked at like hourly energy consumption, daily energy consumption over a period of 3 months to actually find out what's going on. It was a long project. It took us like from concept to implementation, it took about 9 months. But first 3 months were like all analyzing what's actually going on, like what would be the systems which would be better. And then once the data, we were able to understand data, what's going on each floor, then we moved on to the next understanding, which is like how we can, like why the solar is not helping. Next please. So one of the things that we found that like solar, right? Solar is, there are time of use states like Portland, Oregon, or California. They charge you based on when you are consuming the energy. Energy is costly during the evening time. If you are consuming more energy in the evening time, you pay more. But solar is not generating the energy during evening time. solar is producing during the daytime when the energy is not pricey. So you are using the solar energy when you are paying less to the grid. And then evening comes and now you are using the energy from the grid and you are paying more. So that's what this PAE was not saving any energy because they did not have any battery implementation. So one of the things we did was like, how do we bring in batteries? Like why the batteries would be important to save the energy generated during the daytime. When the occupancy is low, we can reduce the HVAC controls so that less energy would be consumed and that energy could go into charging the batteries. We should have the fully charged batteries when the evening comes. When the occupancy is less, we are charging the batteries and taking care of the HVAC using the solar energy. Because the temperature of the HVAC was brought down. Yeah, so bringing the batteries in, implementing various rules to make sure that the energy from the solar is consumed during the evening time by saving it to the batteries. Okay, like those are like some of these strategies we applied there. Next, please. So now this is like what I told you is like separate from each other, but how did we brought it all together? So this was the system architecture that we had. So first electric panels are connected to smart meters. All of that data, Modbus data was going to an IoT platform. Okay. Now I have an IoT platform, like when I talk about edge gateway, like IoT platform, it's very small devices. Okay, I actually brought that device with me. It's not bad. Let me go there and get my. Oh, yeah, okay. So I want to show you, like when I talk about edge devices, what does it mean? Like, so these are like kind of devices, like edge devices. Okay, like these are this is a Raspberry based device, and these IoT platforms are low bandwidth, low space taking software. So we implemented the IoT platform on these kind of small devices. In this we have like the sensors. So the sensors are attached to the car. Like it can do like air quality, it can do temperature, humidity. So the sensors are attached here. So we attached different sensors which communicated using backnet technology. And this IoT platform was able to convert all that data, transfer data into MQTT. Most of the industry is now moving more and more towards MQTT. So this small device was able to take on all these platforms, all these different data protocols and convert this into an MQTT. Okay, so this is an edge device. And then once the data was all transformed, we took it to cloud. Like some of the data needed to definitely go to the cloud because their existing BMS system, building management system, was only on the cloud. So we processed most of the data on the edge, sent only the relevant data. Like time series data is collected every 10 seconds from the sensors, but most of the time, every 10 seconds the data range is not changing. Temperature will not change every 10 seconds. So you're not sending the data every 10 seconds to the cloud. What we did, we collected the data every 10 seconds